So just a second, we are just starting. Good morning, sir. Should we start?
Yes, you can
Okay,
start.
sir. Yes, sir. So, sir, we are Team GATEE SFIT. We are the official go-karting team of St. Francis Engineering College, and today we are here to present the cost report analysis. So our cart number is 112. Team ID is 7064376, and so about Team GATEE, we are the official go-karting team of St. Francis Engineering College situated in Mumbai, and this is our third time we are presenting in this competition. So this is about us. So this is the agenda of our cost report presentation. The agenda for today is cost analysis of every system and parts included in the go-kart, the factor affecting the cost, as well as the cost-saving analysis. So as you can see on the graph in front of us, each and every cost is divided in percentage, and our actual cost of manufacturing the go-kart comes to rupees 1,74,947 rupees. So our cart is divided into 7 systems. First of which is the steering system, then the engine and transmission, then the vehicle assembly and tires, the wheels assembly and tires, the electronics and wiring, frame and body, brake systems, and fit and finish. So moving on to the steering system, I would like my colleagues, Mr. Shivam, to present for the.
Hello. So starting with the steering system, we have steering wheel, which is 1,650. The steering wheel have cost us around 235. The steering column was for 350. Steering support for the steering column was 280. The bearings cost for 3,330. The pitman arm was 145. Tie rod, both left and right, were for 800. The tie rod ends were for 480. And the positive stop for the steering wheel was 30 rupees. So the total cost for the steering system comes to 4,300. Next slide. So next is frame and body. The frame costs us around 17,132. Body mounts 1,830. The engine mounts were for 450. Steering mount for 900. The driver seat mount for 320. Pedal mounts for 60. Brake mounts for 115. Bumpers for 1690, and driver seat for 2600. So the total for the frame and body comes to 25,137. The wheel assembly and tires. The wheels rims for both front and rear cost us for 9,800. The tires cost 9,000. The sub axle both left and right cost us around 3,700. The rear wheel hubs both left and right cost us 260. So the total for wheel assemblies and tires comes to 22,760. The further presentation will be done by my colleague Aryan.
Thank you, Shivam. So moving on with the brake system. This slide consists of the parts included in the brake system along with the total cost. So firstly comes the brake fluid. Brake fluid cost is around 400 rupees. The master cylinder was for 1,220. The brake pedal was for 90 rupees. Fluid line was for 600. The caliper cost is around 3,000 rupees, and the rotor cost is around 1,100. which all totals to about 6,410. The next part is the engine and transmission. So the cost for our engine was 50,000. The throttle for the pedals and cable was for 400 rupees. Exhaust manifold was for 3,500. The muffler cost us around 8,000. Chain was for 500 rupees. Bearing bracket was for 320 rupees. Hub driven sprocket was for 1,400. Clutch wire was for 550. Gear shifter mechanism cost us for 610. Hand clutch pedal 200 rupees. Drive shaft 1,080 rupees. Fuel tank cost us 1,330, which all sums up to be 67,890. The next slide consists of the electronics and wiring parts and their actual cost. So the battery cost is around 1,500 rupees. Wiring harness was for 2,600. Brake light was for 300 rupees. Switches that consist of the kill switch, brake over travel switch, starter switch, ignition or key switch. The all total for that was 850 rupees. The relay cost is 500 rupees. Rectifier and regulator unit was for 800 rupees. Fuel pump was for 2,000. Fuse was 60 rupees. Insulation tape was 20. Zip tie cost us around 100. Connector was for 240. Cable identification tag was 50 rupees. Wiring was 100 rupees, which all sums up to be 9,120. And finally, coming to the fit and finish. So the fit and finish slide consists of the parts and actual cost of a bodyworks. That is the paints 400 rupees, stickers 100 rupees, firewall for 620 rupees, for which the total cost is 1,120. Now, I would like my friend Aaron to explain the cost analysis. Thank you.
Moving on to the cost analysis. So most of our cost is on cost of purchase. That is our engine, which we used a Yamaha engine 150cc FZS, and the other materials that were used. The cost of manufacturing is comparatively less. Most of our things, like the body and frame, the body works and all are manufactured in our college garage. Then moving on to the next slide. Here we have the cost overview. So what we presented was the cost of manufacturing the prototype of a go-kart. But if you go to manufacture it in a large scale for a business, then the cost might decrease of the manufactured parts as well as the cost of purchased parts, as we will be buying them and manufacturing them in a larger scale. So in conclusion, our kart consists of total 83 major parts, and total man working hours of our go-kart was 53 hours. The brake system consists of one manufactured part and 5 bought parts. The electronics and wiring also consist of one manufactured parts, 14 bought parts. Fit and finish is manufactured in-house, but we bought things like the paint and the stickers. For powertrain and drivetrain, we have 6 manufactured parts as well as 11 bought parts. Wheel assembly and tires, 4 of them are manufactured in-house and 3 of them are bought. Frame and body, 18 of the things are manufactured and 5 of the things are bought. Steering system, 7 of the parts are manufactured and as well as 5 of them are bought. Thank you for your time. If you have any questions.
Yeah, Tim, quickly open the cost report that you have submitted.
Yes, sir.
Okay, go to powertrain and drivetrain. Locate any one component that you have manufactured completely in-house.
Hello?
Okay, so this is throttle pedal, right?
Yes, sir.
Explain all the costs associated with this.
So to begin with the raw material cost, so we took a 5 mm thickness plate of MS, which was bought from outside as raw material. It cost us about 40 rupees. Then the process cost, like the labor cost which involved, was about 30 rupees. The tooling cost that cost us was about 90 rupees. That involves all the grinding wheels that was involved, because the grinding wheels and the cutting wheels which was involved in it. And the last one which was involved was fasteners cost, that makes about 20 rupees. That goes for attaching the pedals to the chassis. This sums up to about 90 rupees.
Okay, can you zoom in a little? So cutting, welding, drilling, and grinding. This all covered under 30 rupees? These many drills?
Yes, sir.
Okay. Are these on the surface of the pedal? Are these the drills or extruded points or some knurling?
Sir, it's basically the image over there. Our exact thing will not be that way. It's going to be a flat plate.
But how will then we be able to visualize whether you have performed the operations are according to this design or according to that design? I mean, if the design of the given image is not same as for the part.
So it's going to be as per the design problem.
I mean, you decide and tell me.
Yes, sir. Yes, it's going to be about like the design only. Actually, that type of plate will be manufactured by us only.
So
By
are
drilling
on
holes
the
to
surface
reduce
of
the
the
weight.
pedal, on the surface of the pedal, are they the holes?
Yes, sir.
And how many holes are there?
So probably not exactly that many holes which is presented over there. It's going to be depending upon the weight
Again,
that
the
will be
same
required.
question.
Okay.
Any other component?
Scroll down.
This gear shifter, I think gear shifter link you have manufactured.
Yes, so that also is manufactured along with this hub over here.
Hub you have selected as boat part.
Okay. So it's both like that. Like it was bought in the proper shape over there, but the drills which are shown in the image was done by us.
No, I will consider only what is filled. No.
Okay, sir. So we can take the gear shifter for that then.
Okay.
Yes, sir. This was
Explain the
manufactured by
costs
us.
associated here.
Yes, sir. The fasteners cost us 10 rupees. That goes for connecting the links over there. Uh, the raw material was for about 300 rupees, which involved the SS connecting link as shown over there and the MS bent pipe over there. 300 rupees went for the labor cost, which also includes the processed part. And the last
What
was
all
600.
processes? What all processes does it include?
So there's drilling, grinding, and cutting.
Okay, explain me right like in sequence. What did you do first? I mean, right
Uh,
from the beginning.
So first the material was bought, then it was cut into the desired shape. Grinding was used for finishing the material into the actual desired part, into the actual desired size. Drilling was used in the pipe for attaching the fasteners, and
So there is no
that's it.
bending operation that you did. No bending process.
Yes, the bending was involved over this. Sir. Yes,
But
sir, bending also comes
it's
in.
not mentioned here. How much for each process? Out of 300, how much for each process?
So the bending cost us about 100 rupees, and rest all. Wait, one minute, sir, just a minute.
Bending costed you 100 rupees.
No, sir, no, sir. The bending cost us about 250 rupees per bend
250
because
rupees.
just it was just one bend over there. So per bend cost
What
us
is the
about 250
dimension of
rupees.
this pipe?
So 1 inch.
1 inch OD.
Yes, sir.
So 250 for one bend. I mean, how are you doing this? You outsource this bend?
So it was done on a CNC bend available in our college.
Okay, when you are doing precision manufacturing like CNC bending,
Yes, sir.
so you must also be doing the precision manufacturing with everything else also.
Yes, sir.
So why there is no tooling cost? Tooling costs is written as 0, no?
Yes, sir.
Since you used cutting, grinding, drilling, maybe, not maybe, you must be using fixtures also, jigs and fixtures also. So how can it be 0 for the tooling cost? Okay, how did you validate the manufacturability of your cast design?
So it will be explained by Aryan.
Whosoever.
Yes, sir. So, in order to validate the design of a go-kart, we initially designed a go-kart that was of a simple structure that could be manufacturable.
Could you be please a little bit louder?
Yes, sir. So, in order to validate the design for manufacturing a go-kart, we firstly designed a go-kart with the reference of the previous 2 years go-karts, and we made sure that the design was simple and that was not much complex. After that, the various tests were done on the chassis through ANSYS,
But
and
then, if I say simplicity of the design that
yes,
you
sir.
are focusing,
Yes, sir.
you for just a gear knob, I mean lever, you are doing a CNC bending which is costing you 250.
Yes, sir.
So is it worth doing? Is it that really required? Like the precision required and the reliability of the component needs that cost to be invested upon?
I
I
think
mean
so. Yes.
250 just for a bend.
Yes, sir.
So is it that you intentionally did, or that was just a planning glitch? I would say. I mean, you did not plan in a better way, or you just randomly picked this idea to say it now that 250 was incurred in CNC bending. However, the bending operation or the process you have not at all mentioned in the manufacturing of this component. So how did this answer arrive? I mean, all of you can collectively defend this, because when it comes to validating the manufacturability of your cast design, everything that you are going to manufacture is already decided with what procedures or what methodologies you will be manufacturing each and every assembly or the part, be it anything. Okay, how did you determine the materials and manufacturing processes to be used in your cast design? Okay, what steps did you take in order to reduce the cost of the car while keeping the safety and performance your top priority?
So that answer would be answered by Ms. Fernandez. Thank you.
Guys,
Yes, sir. Okay.
go ahead, please.
Sir, can you repeat the question, please?
I'm saying, what steps did you take to reduce the cost of the cart while keeping the performance and safety your top priority?
Uh,
So the card was manufactured in such a way that it's not very heavy weighted, to keep it light weighted to increase the performance. And keeping in mind the safety stuff, we've also regulated like firewall to protect the driver from the engine's heat and stuff. Also, we have added fire extinguisher also to the card in case if the card catches fire in any way, so we can
Now, how
cut down
did
the
you
fires.
manage to bring down the cost while keeping these things your top priority? This is the question. Okay. Next question would be, just a moment. Okay. Did you redesign any assembly or any part by reconsidering the manufacturing processes involved so that the cost can be brought down, or did you try to reduce the number of fasteners and other things involved in that assembly so that the cost of the uh, complete assembly can be brought down?
So one of these would be the gear shifter, which in order to reduce the cost of the bending and stuff, we might be changing that in some way.
Okay, my part is done, guys. You may go ahead and ask.
Yes, sir, thank you. Uh, and the total man hours employed for this particular project is 53 hours, right?
Yes, sir.
Um, can you just explain me how did you calculate this one?
So it
Take any
was
one case. Take any one case, and then you can explain.
like any one system that
Yes, yes.
just a minute, sir.